Hello, I'm Gordon Ritchie with Kollmorgen, and this is 2 Minutes of Motion. Because of the details in this segment, it will run a little more than 2 minutes, so please bear with me. Many applications don't require a high-level controller, and in these cases, a simple positioner can be used. The AKD-P series allows different motion tasks to be created, and by blending one task to another, create complex profiles. It should be noted that the prerequisite for this segment is the one on homing, since a home must be established before a position move can be made. Within the motion task screen, there are several ways to enter the data for a move. The first method is to enter the data into the table. The table can be expanded to include the start condition and dwell time. The second method is to double-click the task number to the right. The motion tasks start at 0 and ends at 128, and each task can be linked together. In motion task 0, we will enter a short move of 1200 degrees. Our units have already been set up for motor only, and position is in degrees. This move will be an absolute move, and we will link it back upon itself, meaning that it will repeat this move until told to stop. At the end of the move is a 250 millisecond dwell before the next move. We can see in the scope plot that the motor only made one move. This is because the absolute move sent the motor to the position of 1200 degrees. The next time the move was issued, the motor was already at 1200 degrees. There is no need to move any further. Next, we change the move type to relative move, then repeat the motion. We see that the move repeated continually. While the absolute move is in reference to 0, a relative move is in relationship to the current position. Because of this, we use absolute moves when working in finite distance, such as an actuator, and use relative moves when working in motion that can continue indefinitely, such as an index table or a conveyor system. Now we have connected 3 moves together. 2 take the motor out, a total of 4 revolutions, and 1 brings it back to 0. Between the motion task is a 250 millisecond dwell. The blue line represents the digital input, which starts the motion task. The red line is our velocity profile. The green line is our position, which begins at 0 and moves out to 1440 degrees, and then returns back to 0. Between motion task 0 and 1, the dwell is going to be replaced with a blended move. Motion task 0 will be blended into the acceleration of motion task 1. In the scope, we can see that motion task 0 was blended into motion task 1. Using the cursor, we can see that motion task 0's position of 720 degrees is at the point where motion task 1 is accelerating. Now we change the blend between motion task 0 and 1 to blend into velocity. Again, using the cursor to mark the position, we can see that the position for motion task 0 ends at the velocity of motion task 1. By using different blending techniques, velocity, acceleration, deceleration, and dwell times, the complexity of the profiles the AKD positioning drive can make is only limited by your imagination. I'm Gordon Ritchie for 2 Minutes of Motion. I'll see you next time.